Hello. Okay, this video I'm going to demonstrate how to solve the image gallery problems, and I'll try and do it in pieces. I'm going to go fairly quickly because you are able to pause this and slow it down and go back, but I want to get through them all. So first thing I should do probably is open up the gallery instructions, and you should be familiar with them by now. Okay, so our first problem is line of circles. Our job is to write a function. So the very first thing I'm going to do is make a function with a reasonable name, which I can just take from the title of the problem. And then I look back and it says the function should take a single argument that allows the caller to specify the size of the circles drawn. It should draw as many as fit across the width of the canvas. So R will stand for radius, is our argument. And now we have the skeleton of our function. And I can start by just drawing one filled circle. And I don't know, let's just position it at 0. And it looks in this image like they're vertically centered. So we'll do height divided by 2. And the radius is the radius, obviously, and the circles are red. And that doesn't do anything because I haven't called that function. I've defined it, but now I need to add a call to it. Circles, let's draw 23 pixel. Okay, so there's my circle. It's peeking out. It's a little bit off the screen because the center is at 0. And if you remember the slides, we actually have gone through this already. I could set the x value to be the radius, and now it's directly on the screen, just touching the edge. So that's a good start. And now I just need to draw a bunch more circles. So obviously, if I want to do something a bunch of times, I'm going to write a loop, and we'll just start with 10 just to see what's happening. And auto format that. Okay, so now my function is going to run this code 10 times. What's going to happen? Well, nothing different because I'm drawing exactly the same circle each time. In order to draw each of the 10 circles in a line, I got to move them each one a little bit to the right. In fact, I've got to move it one whole diameter. So like the radius plus another radius away. And so that suggests that I want to have a variable to represent the diameter, because then I can say on top of the R that I've shifted everything so that the first circle is just touching the left edge, I'm going to add one diameter for every time we go through the loop, which I can express as I, which is our loop variable, times d. So it'll be 0 diameters, then 1 diameters, then 2 diameters, and that gives me a line of circles. Now obviously 10 is not the right number for this size of circles, so that means we need to figure out how many circles can we draw. So let's call that n, and if you're unsure about that, we could even, sometimes it's useful to, when you introduce something new, is see if you can do it in a way that the code doesn't change at all. So I've just replaced the 10 here with the variable n, so this should run exactly the same, and indeed it does. But now I see that if I change n, it draws more, and 20 is too many. So now we're back to the problem of how do we find the number of circles, and that is, well, if we want to, how many circles can we divide this width into? It's width divided by the diameter of the circles, and then we take the floor because we want a whole number of circles. We don't want a fractional number of circles. Probably, yeah, I think, because I think if we didn't have the floor, we might get a little partial circle there. Yes, drew this last one because the center is still to the left of the, is less than the width, but we don't want to draw a fraction of a circle. So we're going to take the number of whole circles that will fit. And now the last step is we want to center this, which just means we need to move everything a little to the side. I think in the slides I showed one way to do this. I'm going to do it a slightly different way here. So if we divided the width by d and got the whole number, that's how many times something goes in. And really another way to look at what the extra is the remainder. That's literally what the remainder is. So if we take the width remainder d, that's going to give us extra, which is going to be like this extra space, and then we just need to add that into here. Now another thing I'm going to do is say this expression, a little complicated, so let's make another variable Same trick as before. I'm just making a new variable and then using it in the place where the expression used to be. And so this should work exactly the same. And you'll notice extra is grayed out because I haven't used it yet. So I'm gonna, now I know where I need to use it because I'm trying to change the x value of each circle to shift it by half of the extra. So I just add that in. And I could have added it at either end, it doesn't really matter. Okay, so that's one problem down. So what I would advise to do now is comment out this call and keep it down there. And then we're gonna look at the next problem, which as you probably know is the alternating circles. So that's obviously very similar. So I'm just gonna copy and paste this whole thing and give a new name. And then I can even copy and paste this, change it to the new name, and then use command slash, oops, turn the wrong key, command slash to uncomment that line. And so now, and since this is exactly the same, we should end up with the same picture. But obviously, now we want to do something where we change the color. And there's kind of two ways, well, we'll just do the simple way. So obviously when we want to do one thing or another, the construct that we have for doing that, it's a two-way choice. So we're going to use an if, and then we're going to put this line inside the true branch and the false branch. Oh, this doesn't format if it's not syntactically correct. Okay, and you can see that this line never runs because right now we have if true, so we'll change that in a second. Let's look at the picture. The picture starts with the blue one. So our idea here is that when these circles are all numbered, in some sense, by the I, whatever iteration of the loop we're on, I has some value. And so if we, every time we're on an even iteration, we draw a blue circle, and every time we're on an odd iteration, we draw a red circle, we'll get the alternating pattern that we want. So we can write an expression here where we take I remainder 2, and if that's 0, that means it's an even iteration, and we get a blue circle. So all we did to change this into this second one is add an if statement and the two calls to the circle. There's a draw filled circle. A slightly different way to do this is to make a variable that's going to hold the value. So one way we can do that is we could say let color, and this is a thing maybe we haven't talked about a ton or at all, but we can declare a variable without giving it a value initially. But the idea is that we're going to get rid of both of these calls to draw filled circle and have just one where instead of either the string red or the string blue, we just have the name of the variable color. And now all we have to do is set the color in here. So if we set it to blue, it will be blue. And if we set it to red, it will be red. And that should work exactly the same. And now is just one final, this is an advanced, slightly advanced thing, but it's quite handy. It's a little gross to declare this variable and then have this whole big if statement that sets it to one of two values. It would be nice if there was a way to sort of set it once, and that way is there's a special construct that's written with a question mark and a colon that works kind of like an if statement, but in a place where you want a value. So we can copy the Boolean condition from our if statement. So notice that this I remainder 2 equals 0 is the same as the condition in the statement. And then there's a question mark, and there's the value you want if that condition is true, and then a colon, and the value you want if that condition is false. And so the value of this is an expression that gives us one of those two values. And so that basically replaces this whole 5-line if statement. Should work exactly the same. Okay, so this is called the ternary operator. A little bit of an advanced technique, but especially in cases like this, it's quite handy. Okay, so that's 2 down. Now we look at our problems. concentric circles. Not the same as the other, though we will have this alternating color pattern, so we should remember how we did that. Let's just call this target. That's what it looks like. And what does this function should take an argument that specifies how many circles to draw, and then makes the largest circle just fit in the canvas. Everything else is evenly spaced. So we're going to call this variable rings, as in how many rings are we going to draw. And then the largest circle is supposed to fit in just in the canvas. So this is a job, well, it's always a job for making a variable. So let's make a variable called max r, which is the max radius. I don't even spell it out. Max radius. And if in this drawing area, it would be the height, because the height is the smaller of the two dimensions. But if we popped it out and it was taller than it was wide, it would be the width. And so that is a job for math.min, where we want the minimum of the width or the height, whichever one is smaller. And we don't want the radius of the circle to be either of those entirely. We want it to be half of whichever one is smaller. So that if we're drawing, here, let's run this so we have a blank canvas. So if we're drawing a circle that's going to be centered here, we want the radius to be from the center up to here, or the center down. So that's half the dimension. And so we can go ahead and draw a filled circle. In this case, all the circles are centered. So the x and the y are the width divided by 2 and the height divided by 2. And then the biggest circle is going to be max radius. And what do we made the outer one blue, so we'll make this one blue. And then we need to add a call down here. Target, let's draw 8 rings. Okay, well, we're not drawing any rings yet, but there's a circle. So if that was our biggest circle, we'd be all set. And now the trick is to draw however many rings. We just draw them by drawing smaller and smaller circles. And so kind of like in line of circles when we had to figure out, there we needed to figure out how many circles to draw given a size. This time we need to figure out a size. We'll call it, let's just call it size. It's kind of the width of the rings. We don't want to use width, obviously, because that's taken. So we'll just call it size. We can use ring size maybe. So the ring size is if we divide the radius into even parts, we want the rings to be each the same fraction of that, and there's the number is going to be the number of rings. So that's just max radius divided by rings. And as before, we want a whole number. Actually, no, we don't. Sorry, this time we want, it's fine if it's fractional. You know, JavaScript can handle if it's, a fraction of a pixel, whatever. And so now, oops, we're going to draw use our loop to draw the multiple rings. And we know we want to draw rings, number of rings. So that's our loop, I plus plus. And we're going to move our draw filled circle in here. And now the thing that's going to change each time is the radius needs to decrease. So one trick of this, if we're to get the pattern, we got to draw the big circle first, because the second thing we draw is going to cover up whatever's below it. And so if we drew the small circle first and then a bigger one, it would just cover it up. So we're starting from max radius, and we're going to go down. So our max radius, our radius is the max radius minus something. How much have we shrunk it? And each time we draw a ring, we're going to make it one ring size smaller. So very similar to how we spaced out the circles by multiplying I times d. In this place, we're going to multiply I times ring size and subtract that from the maximum radius. So, and one way to check this is when I is 0, the first time through our loop, 0 times ring size is just 0, and so our radius will be the max radius. So the first circle will be the biggest circle that we've already drawn, and then the subsequent ones will be smaller by 1 ring size each time. Now, if we run this, we're not going to see the difference, because we're just drawing a bunch of blue circles on top. We could temporarily see that it's working by drawing a not a filled circle, but just this outline of a circle. And we can see that that looks right if those rings were colored. So now we just have the same problem as we had before, and we can even copy this line of code to set a color variable based, again, on I. So the even numbered rings are going to be blue, and the red ones are going to be, or the odd ones are going to be red. And we change our draw filled circle to use that variable, and boom, we have our third function done. And we can test these, useful to check. For instance, let's check 3, so it's easy to count. Yep, 1, 2, 3 rings. So what happens if we say 1? We should just get a circle. Great. So, seems like it works. All right, checkerboard. This was the one I know that puzzled a lot of you quite a bit. And fairly reasonably so, because this is the first problem that requires a nested loop. We have 2 dimensions. We're going to have one loop that helps us draw horizontally across and another that draws rows down. So let's checkerboard. And what is this? The argument n is supposed to specify the number of squares on each side, and then we're trying to fit it. I guess it doesn't really say here, but looking at the picture, it looks like we're fitting it again in whatever dimension it would fit. So this one is width. If the area was different, it would be height. So we'll just call that n, as n is the number of squares. So we'll add checkerboard down here. Checkerboard 8, we'll draw regular chess or checkerboard. So now we can sort of start to see the pattern. We're going to introduce some variables, and we're going to make some loops, or maybe we'll even make, in this case, sketch out the loops first. So as I mentioned, this one requires, actually let's do it in steps. So we're gonna make one loop. And let's just see if we can draw a row of checks. So we have a similar trick to, what are we doing here? So we're gonna draw this time a draw filled rectangle. It's gonna be at some position. We'll go all the way back to what we did when we were drawing our line of circles. We're just gonna draw it at 0. We'll do height divided by, actually let's make it, we'll just put it at 0, y, and then draw filled rect takes 4 arguments, so x, y, width, and height. Obviously it's supposed to be squares. And so this is gonna draw n, in this case 8, squares are all gonna be blue. And so we're really gonna get just like a long blue rectangle. Oops. Sorry, we're drawing them all at the same position. That obviously doesn't do anything. So let's go ahead and introduce a variable here. We're gonna say square equals 20. So same trick as before, we're replacing a literal number with a variable, because here we want to move them over. So we're gonna, the size of the square times I is gonna lay them out. Now we can't see the difference, so let's go ahead and grab our color alternating expression and format that. Okay, so now we've got the basics. Now obviously these are not big enough because we just made them be 20, they're not centered, and we only have one row of them. So let's maybe work on the sizing issue. So this is a little bit of a combination. The line of circles was always constrained by the width, but the checkerboard, since it's a square, can be constrained by either the width or the height. So I copied this max radius, but instead of the radius, I'm going to call this the size. Maybe board size is kind of clear. So it's just, and it's, this time it's actually going to be the full width or the full height, whichever one is smaller. So on this drawing area, the board is going to be constrained by the height, and then we're going to have to center it. So we can get the extra x, which will actually be something on this drawing area, as the width minus the board size. Can't use remainder here because we're not actually filling up the whole width, so we're just going to use subtraction. And the extra y is going to be the height minus the board size, which one of these will be 0, and that's fine. But we don't have to know which one. It just depends on whichever one of width and height was smaller. So we've got the size of our board. We've got some variables that tell us how much we need to shift it over, either in the x dimension or the y dimension. And so then we can go ahead and, actually I'm going to make 2 more variables. I'm going to make a top variable, which is the top of the board in the y dimension. And that's just going to be extra y divided by 2. And actually, so maybe we could have just, that's fine. We could have, this is probably the only place we're going to use extra y and extra x. So we could have defined these. I'll leave it like that. Sometimes it's useful to have names for things. So these are all very simple. We just look at what they do, and then we use the names to tell what they're for. Okay, so we've got a top and a left, which is going to be like the XY coordinate of the top left corner of the board. And now we can also compute the size. Since we have the board size, the square size is just the board size divided by n, right? If we're going to have 8 squares and the board size is whatever it is, the square is 1/8 of that, or 1/n of it, if it, in this case 8, but if n was something else, it would be something else. So this may seem like a lot of variables, but now that we've got them, we're kind of ready to go to town. So we're going to make our, each individual check of the checkerboard is going to be drawn at the top, the left is the x coordinate of the whole board plus the square times I here. And the y is going to be at the top plus, well, we don't have 2 dimensions yet, so let's just draw it at the top for now. Let's see what this does. Look at that. So that looks pretty centered. It looks like 1 row, and maybe even looks like if we drew 8 rows, it would fill up this thing with the square. So now is when we need to add another loop. So first I'm going to do, show you a feature. I've shown it to some of you in class. If you ever have a variable that you don't like the name of, like I, why is I the column number? I'm going to go ahead and change that by clicking on the variable name and choosing rename symbol. And then I can just type the new name, and we'll fix all of the places that that variable is referred to. So C stands for column because we're using it to adjust the column position, or what column we're in, to adjust the X position. So now let's add a loop around the outside of this. And this loop, we'll use R, which stands for row. It's also going to loop up to N. And then I'm going to fix the indentation with my format. Okay, now I've got this loop that's going to draw N rows. This loop is the loop we already wrote that draws one row by drawing N columns. And so now we should just get nothing because we're not changing the top value. So to change the top, we need to add, similar to how we added 1 square's worth for every column that we moved, now we need to add 1 square's worth for every row that we go down. And now we're close. And a lot of you got here and then got a little stuck on how do we make these alternate properly. And there's a bunch of different ways to do it. One sort of obvious way is we could go back to, I'm going to just comment this out because the problem here is that you can see we're only changing the color based on the column. So you might notice that like, okay, this row is supposed to be blue, red, and so on. But the next row is supposed to start with red and then go to blue and red and then blue. And then we're back to blue, red. So you might notice that the even numbered rows start one way and the odd rows start another. So one way you could do is we could go back to our whole, setting the color with a complicated if statement. So if the row is even and the column is even, then the color should be blue, and we can write this all out if we want. It'll be one way. So like, and then if the row, or actually let's, and maybe this is easier. So then we're gonna say, and then if the row is even and the column is not even, is odd, then the color is red. And if the row is odd and the column is even, what should that be? So the row is odd. So that's like the row number 1. This is row 0. This is row number 1. And the column is even, column 0. That should be red. And then finally, we can just use an else because there's no other option. Okay, so I think, oh, what did I do? Row is even and the column is even, it's blue. Row is even, column not even, so I'm doing, that one's red. I'm getting some extra blues. Oh, sorry. That should be row not equal to 0. There we go. Okay. So that's fine. And if you did it that way, congratulations. You definitely worked it out. I'll just note there's another way to look at this, which is to say the two places that it's red is when either this one's even and this one's odd, like equals and not equals, or this one's odd and this one's even. So another way to say that is if the value we get from the remainder of the row and the remainder of the column is not equal, then it's going to be red. And really in all other cases, it's going to be blue. So we can simplify this a bit. And you might want to run that back. If that didn't make sense to you, like go back and make sure you understand what I just did, because it does indeed work. And that's simple enough. We could use our friend the ternary operator, but there's an even simpler way, maybe, arguably, which is to note that when, if we have an even row and an even column, that's when we get blue. And when we get an odd row and an odd column, that's when we get blue and everything else is red. Well, what happens when you add two even numbers? You get an even number. What happens when you add two odd numbers? Like, so 2 and 4 is 6, which is even. 1 and 3 are both odd. We add them together, we get an even number. And that's true in general. Two odds make an even, two evens make an even. So the only way you get different, like an odd and an even, if you add them together, you get an odd number. So that suggests that we can even, no pun intended, just add the row and the column and see if that is an even number. And this might flip, I think this is going to flip the red to the blue, but I think it'll still be a checkerboard. Indeed it did. And so now this is also simple enough that we can go back to using the ternary operator if we want to be fancy. So we just get rid of the extra parentheses and say if that, make it red, or blue. And so now we have an expression that instead of just using the column, uses the row and the column to give us the checkerboard pattern. And if we wanted the blue to be first, we could swap it, which is which one is which. All right, so we don't need that. So other than setting up a bunch of variables, and the fact that there's two nested loops, this is also pretty simple. We just have an expression to figure out what color we want to draw, and then one call to draw fill rect that maybe is a little hairy. We could actually make this a little more clear by pulling out these expressions. So the X, just to so it's sort of more readable. Oops. So we'll put the X there, and then we'll take this and make that Y. And it works just the same. And then we can finally go back here, the thing I was talking about before. We never really use extra X and extra Y except for right here. So we could just set top directly. So top comes from the Y actually. Boards, height minus board size divided by 2. And we don't need extra Y anymore. And likewise, left comes from width minus board size divided by 2. And now it's not quite so top heavy with all those variables. So we've got our board size, the top, the left, the square size, and then inside the loop, we have some variables. And note that const means we won't change the variable. That means we never reassign it a new value. And you might say, well, don't we reassign it every time through this loop? And the answer is no, because each time through the loop, we're in some sense making a new variable. These variables only last for as long as this body of the loop is executing. And then if we iterate again, it's a new set of variables. So they're changing in the sense that each time through the loop, they have a different value, but we're not reassigning them. So when you can declare them const like that, it makes it clear that what's going on. Okay, so that's 4. I think we're halfway done. And of course, feel free to pause this video. I know we're this kind of a fire hose of information. All right, not really curved. Another one that's a puzzle, mostly because it's a little maybe tricky to see what's happening. But in coding wise, it's actually in some ways simpler. So this is going to take an argument that specifies the number of lines to draw. So the key insight here is that this problem is just drawing straight lines. And the curve just is an artifact of the way the lines are positioned. We get this sort of, it creates a curve. And so if you look carefully, you'll see there's essentially a line being drawn. You can think of it, the first line is being drawn from up here where my mouse is, straight down the bottom edge. And then there's a line that starts, let's go further down. Then there's come all the way down here. This line starts sort of in the middle of the vertical. And if we just have to sort of follow it through that curve, it's going to come out kind of in the middle or something of the horizontal. And so what's actually happening is each line is drawn, as we move down here, we move over to the right there. So it's just actually one set of lines being drawn from decreasing y positions and increasing two increasing x positions. So let's see what that looks like. Some usual stuff to figure out the size. I'm going to use the same. This is kind of like the checkerboard, and or at least the way I drew it here. It's drawn in a square. A lot of you just drew it to fill up the whole thing, and that's fine too. It didn't really say, but let's just for fun make it draw a square so everything's even. And then we'll actually can grab this. So the top and the left. And then n is how many lines we're going to draw. And if you note in the picture, these are evenly spaced down, like each of the distance between these lines is evenly spaced. The distance between where they touch the bottom is evenly spaced. So we're going to want to make a variable. Maybe we'll call it step, which is going to be the size divided by n. And now we're going to write a loop. And again, just a primordial loop that's going to loop n times. And my preference is to write loops like this and then let the math happen inside the loop, rather than writing a loop variable that's going to change by step or something. So draw a line takes x1, I'm just going to put this here, x1, y1, x2, y2, and then I think a color. In fact, if we want to test that, we could just say, all right, let's draw a line from, all right, we'll just totally test it. We're just going to see if this should draw a diagonal line across the whole area. And not really curved. Take some argument that we're not presently using. Oops, I copied and pasted, but didn't change the variable names. Okay, so draw a line works the way I think it does. Okay, so now let's think about the starting point of our line. What did I say color here? That should be black. The starting point of our line should be the x should be the left edge of our thing. And the y should initially be the top. So maybe we're going to draw the first line, and then it's going to go down. So it's still going to be on the left, maybe plus the step, or maybe the first one is going to be, we'll see. No, we probably want one that goes straight to there. And then finally, the y is going to be the top plus the size. So this is going to draw the same line over and over again, but it's going to draw that. It actually drew a bunch of them, drew 10 of them, but they're all in the same position. So now we got to think about what's actually changing. So the x value of the starting point is always going to be left, so that's not going to change. But the top is going to come down. Start at the top, come down by one step each time. So we now maybe guess the pattern for that. I starts at 0 minus step. So the first time it will still draw from the very top. And then it's going to draw 2. This is x, this is y, and then this is the other x. Now the x needs to increase moving out this way. And it's going to increase by the same amount. So also I times step. So again, when I is 0, it's just going to draw this line. Okay, what did I do wrong here? Looks like my top is way up here. So the top, maybe I did this wrong. Height divided by size. Oh. No? What's happening? X. Top is the y value. Oh, wait. Oh, that's right. Width minus size divided by 2. Step. Size divided by n. All right, so this is actual debugging. I'm gonna check if I draw a thing from the top left to the top plus size, left plus size. Does that draw a diagonal line sort of describing? No, that does not at all. What is going on here? Oh, sorry. Left, top, and left plus size, top plus size. All right, left, top down to, okay, that's looking promising. So I'm just trying to figure out like where this, that looks like it's drawing in the right square. So let me come back to here. And inside our loop, we're drawing from left to, oh wait, should that be top? There, I don't know, mine, okay, great. Look at that. Okay, so there we have it, a plus, it was a, I had a minus where I should have had a plus. And then I did some just simple checks to make sure I understood roughly how things were working. And maybe notice that we have this line straight down, but there's not really a line at the bottom here. So that suggests that maybe we want to make one slight change to our otherwise normal loop and go all the way up to n, because that will give us a bottom line where the y value is all the way at the bottom of the square, and likewise the top. And this one is worth popping out. Whoops. Oh, I guess it is basically working. Looks a little funny. Let's make the size just a little smaller so we can sort of see it when it's not on the edge. So I'm going to make this the smaller of the two times 0.9. Now when we pop it out, it should still work. Still works that way. Okay, that is in fact working. And now let's try it with more 25 lines. And now we start to get the real curve. Okay, so I'm going to call that good. That one took a little longer than we meant because I got confused by a simple arithmetic. I forgot for a second that which direction the coordinates go. I was starting at the top, and going down means adding to go down, not subtracting. So that's an easy mistake to make. Some of you may have stumbled over that. All right, but we've survived. And I got 3 left. Okay, and they're very similar. So const fill, what did I call it? Fill with circles. Fill with circles. And this one is back to accepting a radius, which we'll call R. And this is basically a combination of sort of the 2D pattern of the checkerboard plus the tricks we've used for centering things. So we got to figure out how many rows we can fit. And that's going to be a floor division of the width. Sorry, rows is height divided by the radius. The number of columns we're going to draw is going to be the floor division of the width divided by the radius. And then extra x is going to be, so x has to do with columns, so that's going to be the width remainder of the radius, and the extra y is going to be the height remainder radius. And I think maybe we're ready. Oops, I keep writing Java. Row equals 0, row less than rows, row plus plus. I'm not using R here because R was radius, because I could have use the big word for radius. That's fine. And then I'm going to have another loop like we did in the checkerboard. This is the variable is call, and while it's less than columns, it's going to go up. And now I've got the structure in place. I'm just going to draw a circle, and maybe we'll make variables here. So the x value of my circle is going to be the extra x divided by 2, just like we did in line of circles, plus the radius, plus, what column we're in, times, and let's go up here, whoops. And that actually reminds me, when we're seeing how many are going to fit, it's not the radius we care about, it's the diameter. So all of these really should be the diameter. Column, the current column times the diameter is our x value. Our y, very similar. Extra y divided by 2 plus r plus whatever row we're on times the diameter. And we draw our circle at x, y, with our radius r and our color of blue. And nothing happens because we're not calling that. Fill with circles 23, and there it is. Now, like with the alternating circles, the next one is going to be so much like this that we just copy it. What is this called? Fill with circles randomly filled. So it's kind of a long name, but tack it on there before I forget. Copy that, comment that one out, randomly filled. And this time, our color variable, we can just set randomly. So I'll just go ahead and use the ternary operator. If the random number we get from calling math.random is less than, this one is supposed to take 2 arguments. The second is the probability that any given circle is drawn filled in. Whoops, I'm misremembering. Okay, so it's not actually the color, it's what function we use. So I'm not gonna do that in the super fancy way. So we'll just do, this one will do a regular if. So if the random value we get, and so we're gonna pass some probability like 0.2. So there's a 0.2% chance or probability of filling the circle. So if the random number we get is less than that probability, then we're going to draw a filled circle at the same position, same radius, same color. Otherwise, put the next line in the else. And so now if we draw a random number, if it's less than our probability, we fill in the circle. Otherwise, we draw an outline of a circle and whoops. Color is not defined because I got rid of it. There we go. And so each time I draw it, this one is really fun if you pop it out and it just draws the filled in ones. Okay, great. And so now almost there. If you've stuck it out in one sitting, it's kind of amazing. Hopefully you've taken a break, but square of circles. Let's look at what this is supposed to take. This one, we're back to specifying the size, and then it should draw a square that of circles of that size that fit. So this is, again, similar to other problems. Oops. So this one is not actually copied from that so much, but okay, so we're going to have our, we're drawing circles of a certain size, so we want to know how many per side. So let's just call that n. And that's obviously, like if it was constrained by the height, it would be the height divided by the diameter. So let's define our diameter as 2 times r. So it'd be height divided by d, just like in line of circles. We'd take the floor of that. But if it was constrained by the width, it would be the width. So we're going to combine math.min of width and height. So that'll give us the smaller of those two dimensions. And then we're going to divide that by d and take the floor. And that's how many circles we're going to draw in our square. And so one way to do this, a little bit cheaty, but we can guess we're going to need to use two loops, nested loops, because we're going to one loop to draw the rows, and then within each row we need a loop to draw the columns. Whoops. This time I'm going to use radius. Okay, so I can use R and C, C less than N, C++. So nested loops to make a thing in 2 dimensions. Each loop is running the same number of times because we're making a square. And if we just draw a circle each time, we'll just have a big square of all circles, kind of like the filled circles, except in a square. Let's figure out where they should be. Probably need some more variables up here. Actually, I'm going to go ahead and extract that expression because we need it twice. So the size is the floor, and this is a lot like the other one. So the extra x is the width minus size. Extra y is the height minus size. Again, one of these is going to be 0 because the size is going to be either the width or the height. And so then our x value of our sort of the base, the x value is going to be extra x divided by 2. So the thing will be, the row will be centered, plus the radius plus the column times the diameter. The y is going to be the extra y divided by 2 plus the radius plus, sorry, that should be radius, plus the row times d. Draw a circle at x, y, radius, blue. And I think this will draw, if we call it square of circles, a whole square of circles. Oh wait, it's not centered. What happened here? That's curious. N extra x, height minus size. Did we use R somewhere? All right, it's a mystery. What's going on? X looks centered. So here's a good way to analyze loops, which is, I think I've mentioned. So let's start on the very first one. So when R is 0, our x value, which seems to be right, is the extra bit of x divided by 2 plus the radius plus whatever column we're on. So times d. And the y is the extra y divided by 2 plus the radius plus whatever row we're on. So when row is 0, that's going to be nothing. So it's going to be extra y plus radius. Extra y on this screen should be 0. We can even, so one trick we can do is, I think this works. When we run this, okay, see what came out over here is 0. So extra y is 0. 0 divided by 2 plus the radius of the circle. And when r is 0, what on earth? Oh. Haha. Okay, so that's a little subtle. I don't know how to exactly describe this. So the size is sort of, is the size. Why? All right, I might have to edit this video to take out this however many minutes I'm going to be confused here. Or maybe I'll just leave it in. So if the the size, okay, this is like the size of the circles is not actually, because of the floor, the actual size that we draw is not the size that we computed, it's n times d. I think we did this, that's like in the version of line of circles that I did with the slides. All right, okay, so let me just explain what I did. So the size is actually the width or the height, but once we divide to see how many circles will fit, we're actually left with some extra, not just because one dimension is bigger, but both dimensions might have some extra. And that difference is the leftover from the main, like the dimension, the height, and then the actual size in terms of like how far it is from the top of this square of circles to the bottom is the number of circles times the actual diameter. And so that's, but this actually demonstrates something useful, is that the problem was just in my definition of extra x and extra y. And so once I realized I was using the wrong thing here, I fixed those definitions, and then it automatically fixed everything else. Because this code was all right, assuming that extra x and extra y were defined properly. So the bug was in 1 or 2 variable definitions. So that's now fixed. And let's just pop this out and make sure that's still true. And you can see as it gets constrained by the width or the height, it does the right thing. Okay, fantastic. However, this is not quite doing the right thing because it's not drawn, right? It's only supposed to be the outline of the square. And so, as I mentioned earlier, we're going to do this in a kind of cheating way, which is we're only going to draw the circle if it's on the border. So I'm going to start by just making sure this works. So if true, which is always true. Okay, so now we just got to put something smart in here. And basically, the border of the circle is when the row is 0 or the row is n minus 1. So if it's in this row, row is 0, we should draw all those. Or if it's in this row, or the column is 0, or the column is n minus 1. And all the other ones, like if we're in a, if we're in a different, this row, well, the rows aren't the right ones, but the column is. But all these ones in the middle get taken out. So this is, the reason I say this kind of cheating is that this is slightly less efficient. So if I make this to be 2, it's still fine. It happened instantly, but it's looping a bunch of times and not doing anything most of the times. I guess if we were concerned about that, one thing we could do is we could move these 2 lines of code. Oops, keep hitting the wrong thing. In here. So now first we check, are we going to do anything? And if not, or if we are, then we do all the computation we need to draw the circles. So that's that. There are other ways to do it where you basically draw the row, and for each row, you either draw a full row across or you draw just 2 circles, and you could make that a little more efficient, but hardly worth it. And this video has gone on long enough. I'm not going to try to do that. This is a perfectly reasonable way to do it. We had this little bug here, and we got past that. Okay, so this was probably a pretty long video. Like I said, hopefully you haven't watched it all in one sitting, but if you did, more power to you. And let's just see what happens if we uncomment everything. Great, fantastic. I'll leave it at that. All right, hopefully this was helpful.